Happy review morning. I hope that everyone had a good evening last night and that you're ready for this review. Maybe you've had a chance even to look through this. I know you had a little bit of time yesterday in class. Anyways, a couple of reminders. One, we will take that test tomorrow. And two, remember, today is not ideal. I would love to be there so I could answer any extra questions that you might have. But we have to keep moving forward. So this is just a review. You've learned all this stuff already. So just remember that. Don't stress more than you need to. You've already learned all this stuff, so it's just a review. Again, I told you already that we're not going to be doing 13 and 14 because we haven't done the quadratic formula. So you can mark those two out. But let's begin. I know that I went through number one, I think, with one class yesterday. There are a couple questions where the calculator is going to be handy. So tomorrow during the test, you're going to be able to have your Chromebook out and also a calculator. So there'll be a point probably where I'll ask you to close your Chromebook once we get past a certain question because you don't need it for the entire thing, and I don't want it to be a distraction during the test. So let's go ahead and get started, and we're going to start with Desmos, okay? I'm going to go take this equation and plug it into my Desmos. So that equation is negative 2x squared. And again, you can access all of the same stuff that I have with your keyboard. So we have negative 2x squared, and then plus 16x, and then minus 23. And it gives you your graph. A couple things about that graph. Remember, and I almost tried to click on it like this, but I'm using my iPad. You want to know your vertex. Your vertex here is 4, 9. But also, just to make sure you have a pretty nice graph, go ahead and access what these points are. And all I need from you on your test tomorrow is just a quick sketch. So here we see it's just shy of 2, and it's just past 6 on the x-axis. You don't have to be perfect, but just shy of 2 and just past 6 with a vertex of 4, 9. So let's go back to our paper because we've got everything we need. Our vertex was 4, 9. So let's go locate that. That's 1, 2, 3, 4 to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9 up. So I got my point here. And remember what we said? It was just shy of 2 and just past 3, 4, 5, 6. So those 3 points is enough for me to get a quick sketch of what this parabola looks like. And then, of course, we can answer all of the questions that they ask. So first, let's start with axis of symmetry. I talked about that yesterday with both classes. I also talked about this a lot when we were covering it. Remember, the axis of symmetry is the vertical line that goes right through the vertex. So we said that your axis of symmetry is always going to be an equation. X equals the x value of your vertex, always. So since the x value of my vertex is 4, my axis of symmetry is x equals 4. Remember, your axis of symmetry is not 4. If you write 4 for your axis of symmetry, that's not an equation that represents a vertical line. It has to be x equals the x value of your vertex. So x equals 4. Please make sure you understand that. Now, moving on to domain. Remember, we talked about this a lot. Domain is x. What can x equal? So as I look at this graph, as it goes down and to the left, does it ever stop going left? No. As this one goes down and to the right, does it ever stop going right? No. Those are arrows. It never stops going left, negative infinity. It never stops going right to positive infinity. Your domain for all quadratics, will always be negative infinity to positive infinity. So please remember that. Now, range is different because, look, range is y, okay? Remember, domain is x, range is y. So will y keep going down forever? For sure. Look, these arrows are both going down. So it'll go down forever. So it's definitely negative infinity as the smallest value. But what about the highest value? Will it keep going up forever? No, clearly it stops. And it will not go any higher than this y value right here. So what is that y value? Well, it was the y value of your vertex, 9. It will not go past 9. Now it gets there, and that's why I use a bracket, but it never goes above 9. So there's my domain and range for that function to the left. All right, very simple. Your calculator will get you your graph, it'll get you your vertex, and then from there, all the other things are tied to that vertex. All right, let's move along and let's look at the next one. I'm just going to X that out and then retype the new equation, which is 2, open parenthesis. Then I've got x plus 3, close parenthesis, squared, typing it in just like I see it, minus 4. And there's my graph. Again, I'm going to find these 3 points. The vertex, which is negative 3, negative 4. And I'm going to find a couple places where it crosses the x-axis. And that one is about almost negative 4.5. And this one is almost negative 1.5. Again, you don't have to be perfect. So I'm going to go to negative 4.5 and negative 1.5. So negative 1.5 is here. And negative 2, 3, 4.5 is about right there. And then remember your vertex? It was negative 3, negative 1, 2, 3, 4. Right there. So that gives me a perfect graph to just give me a quick sketch of this parabola. All right? Doesn't have to be a perfect graph, but it does need to start with your vertex, and it does need to cross your x-axis in pretty much the right spots. Doesn't have to be perfect, but pretty much right. So now again, let's start with this vertex. We knew it was negative 3, negative 4. So again, once you get the hang of this, finding the axis of symmetry should be easy. It's always x equals the x value of my vertex, so negative 3. X equals negative 3. We already said domain never stops going left. Sorry about that. It never stops going right, so my domain is negative infinity to positive infinity. And then, of course, my range. Now, again, look at this range. Does it go down forever, this graph? No, it can't go past this point. So it can't go past this value of y. What is that value of y? Well, again, it's the y value of my vertex. So it cannot go below negative 4. So this time I put it on the left side because that's the smallest value. But will it go up forever? Absolutely. It'll go up for infinity. All right? So there you have it. The first 2 questions, you get to use Desmos. You can find your vertex, and then from that, your x-intercepts, graph it, and then the rest kind of just falls into place. All right? All right, let's keep moving along here. You don't really need Desmos for number 3. The graph is already given to you. It just asks you a couple of questions. I'm going to start with the easiest one because I think it's important to recognize, does this have a maximum or a minimum? Well, remember, the vertex tells me whether it's a max or a min. Is that a higher point or is that a lower point? Well, it's clearly a lower point, so it's a minimum, okay? So this one has a minimum. Now for the next 2 things, I want you to picture what it's doing as we move from left to right, okay? Now, we're also going to assume that these are arrows on here. They're going to keep on going left and right, that they don't just stop there. So I hope y'all just saw me do that. But let's start with increasing. the interval of increasing. As we move from left to right, do you see where the graph is increasing, where it's going up? It started right here, and it's increasing as it goes up and to the right. Y'all see that? That's where it's increasing. So remember, we are naming that as it pertains to moving from left to right. So we're focused on X. So at what spot did it start going up? Did it start increasing on X? Well, it started increasing as it left 4. And again, if you look at the shading, how long is it going to go up and to the right? How long will it keep increasing up and to the right? Forever, right? So it's going to keep increasing from 4 to positive infinity. And that's how I name my interval of increasing. We've already done all this. Now let me answer a quick question. Why don't I use a bracket? Because technically it's not increasing at 4. It's increasing as it leaves 4. So that's why we use a parenthesis. We don't use a bracket. Now the decreasing, we see it. Hopefully you see it. It's decreasing from when we first see it all the way into that same value, which is 4. So it's decreasing from as soon as we can see it all the way to that same value of 4. So how do I name that? Well, where did it start over here on the left? Negative infinity. All the way to that same value of 4, and those are my intervals of increasing and decreasing. Now, obviously, I'm writing all over this, and I can erase it quickly, and you can't erase it, and I apologize for that, but I want to erase this real quick to talk about this next thing. The next thing, it says negative interval. Remember, positive and negative intervals are defined by where it is in relationship to that x-axis. Okay? Positive are all the values above it. Negative are all the values below it. So this one's specifically asking about the negative interval. The negative interval, of course, is all of this. This is the negative interval. So how do I name that? Well, again, I name it as we move from left to right. So where did it jump down on the x-axis? Where did it jump down below where it became negative? When it went through at 2. And it stayed below, it stayed negative all the way till it came back out at 6. So my negative interval here is from 2 to 6. So pretty simple question. I think you guys will do just fine on that. All right, let's move along here to number 4. Number 4 and number 5 have to do with transformations. Transformations. Remember, there are 3 types of transformations. You can go back and look in your notes. Those 3 different types of transformations were dilations. Remember, dilations are when something's being multiplied, and you can multiply inside, that's horizontal, or outside, that's vertical. We also had what we call translations. Translations were also referred to as shifts. I guess I should have said that the dilations we also called stretch and compress. Hopefully you guys recall these. Y'all did pretty good with these. So just need a little review, and then you'll hopefully do good again. And the third one was reflections. So remember, dilations is when there was multiplication. Translations was when there was adding or subtracting. And reflections are when you were multiplying by a negative. And all of these things can either happen outside or they can happen inside. Outside is vertical. Inside is horizontal. We talked about all this. So it wants me to take this parent function, f of x equals the absolute value of x, and it wants me to write an equation based on all the things here that it's saying. So I'm going to go ahead and I'm going to write f of x equals, and I'm going to go ahead and put my absolute values And I'm going to go ahead and put X in here, and then we'll see all the things that we need to make as far as transformations. So let's start right here at reflected across the X axis. Remember, that's a reflection. And reflections mean that we have to multiply by a negative. But it says across the x-axis. So I want you to picture this. If I reflect over the x-axis, if you were to picture this, you're going vertical reflection. It's going over the x-axis. So that negative needs to be out front. Okay? Then it says it is shifted 4 units right. Right. Right is horizontal. So it's going to be a translation. It's going to be inside because it says right. Now, if you guys recall that we would think right means positive 4, but hopefully you guys recall that when it's on the inside, it's the opposite. So instead of being a positive 4, it's going to be x minus 4. Then it says that it's vertically stretched by a factor of 4/3. Again, vertical happens outside. Stretching tells me I'm multiplying. So I'm multiplying by the value 4/3. So that 4/3 needs to be on the outside, and it needs to be with that negative. Now mine got a little crowded. I'm going to move it over just a touch. So my answer, because that's all of them, look, it says write the equation. So we've done all 3 of these transformations, and it left me with negative, reflection across the x-axis, 4/3, vertically stretched by a factor of 4/3, times the absolute value of x minus 4, because it shifted right 4. So there's my 3 transformations. This is my new equation. All right? Next one. It says the graph of the parent function, we're doing x squared this time. So I'm going to go ahead and I'm going to write f of x equals, and I'm going to hold off on the x squared because I don't know if anything's going on inside yet. If something's going on inside, I need to have parentheses. So let's see what it tells me. First it says it shifts 3 units up. 3 units up. Now remember, up is vertical. Vertical happens on the outside, and it is what it is. When I think of up, I think of positive. So sure enough, at the very end of all this, we're going to have plus 3 because it shifts 3 units up. But it does also say that it shifts 1 unit left. So sure enough, there is going to be parentheses. So that x is going to be inside. But now remember, 1 left. If I think 1 left, I think of negative 1. But we know that on the inside, it's the opposite. So it's got to be a plus 1. And then the last one says it's vertically compressed by a factor of 1/2. Remember, vertical, that's outside. And compressing just means we're multiplying by 1/2. So I'm going to multiply by 1/2 outside. And that's all of my transformations. 1/2 times, in parentheses, x plus 1. On the outside of those parentheses, squared plus 3. So those transformations, hopefully you guys feel comfortable about them. Let's move along to number 6. 6 and 7, you could do these with your brain. You could also, just full disclosure here, you could also use your calculator. You could go to Desmos, and you could graph every one of these if you want and see which one has a vertex at +1, +3. I'm not going to do that. I could. I'm not going to do that. I do want to show you guys the math way or remind you of the math way. But you could graph every one of these. I'm not going to stop you to see which one gives you a vertex at 1, 3. But hopefully, after what we just discussed, remember, if that's a +1, that means that it has shifted to the right 1. It shifted right 1. Well, if it's shifted right 1, on the inside, again, +1 is going to look like -1. So that eliminates this one and this one. But then remember, on the outside, it is what it is. So positive 3 is going to look like positive 3. So positive 3, that fills that, that does not. So my answer here is B. Now, in my opinion, knowing the right way to do it is faster in this case. When it's already in what we call vertex form is really simple to see that vertex. Now, let's move over here to number 7. And again, if you want to use your calculator to find an axis of symmetry of x equals 2, let me remind you, let me take you back up here. What was my axis of symmetry always the same value as? The x value of my vertex. Look, you can see it there. You can see it here. The x value of my vertex. So on this problem right here, shouldn't 2 be the x value of my vertex? Well, absolutely. So you could go graph all of these and see which one has an x value on your vertex as a 2. Now, real quickly, down here, these are in vertex form. And since those are in vertex form, which you can tell because of these parentheses, that is the opposite. So wouldn't that be x equals negative 2? And therefore doesn't match up. And then this one's just a whole different number. It's x equals 4. So there's no way it's C or D. So mathematically, I hope you guys can tell, these are what we call standard form. And I taught you guys that when it's in standard form, you can find your axis of symmetry using x equals negative b over 2a. And remember, b is always your x coefficient, and a is always your x squared coefficient. So I could quickly go like this. Negative b, which is negative 4, right? Divided by 2 times a, which is positive 1. Well, negative 4 is positive 4. 2 times 1 is positive 2. And 4 divided by 2 is 2. Does that match up with this? Absolutely. So it looks like my answer is A. But let's just check real quick, make sure we didn't make a mistake. This one is negative b, which is negative 12. See it right here? Divided by 2 times a, which is negative 3. Well, negative 12 is positive 12. 2 times negative 3 is negative 6. What's 12 divided by negative 6? Negative 2. That does not match. So it does, in fact, happen to be A. All right, so that is one way you can do that. The other way, like I said, is if you graphed every one of those, which doesn't take too long. If you graphed every one of those, only one of them would have an x value of your vertex of 2, which has to match the axis of symmetry of 2. So hopefully you guys recall. Let's keep on moving. One last one that has to do with transformations. So real quick, let's go through this. You're multiplying by 2/5. Remember, that's outside, so it's vertical. Now, was it stretch or compress? Well, remember, the value is smaller than 1. Smaller than 1. 2/5 is smaller than 1. Well, anytime it's greater than 1, your graph has to get more narrow. Anytime it's less than 1, it has to get wider. So sure enough, what move vertically causes it to get wider? A vertical compression. A vertical compression. All right, next, we've got -7 inside. So that's horizontal shift. And remember, horizontal shift is the opposite of what it looks. So that looks like a -7. It's actually a +7 horizontal shift. Well, a +7 horizontal shift means right 7. And then lastly, we've got this -2 that's outside. Okay, it's vertical shift. It is what it is. So what direction do I go for a -2 vertical shift? Down 2. Down 2. And there's our 3 transformations. Okay? Don't pick more than there are. There's only 3 transformations. Only pick 3. And there you have it. Okay, we're moving on into factoring. This should be a little more familiar to us. It's something that we've done pretty recently. So we're going to just factor. It does not say equals, no equals. So we're just factoring. So here's my process. Is there a GCF? No, no greatest common factor. Is it 1, 2 terms? No, it's 1, 2, 3 terms. So we've talked about factoring this into 2 binomials. And the rules go like this. To multiply to get x squared, these both have to be x. To multiply to get a negative, you have to have a positive and a negative. So these things are working against each other. Now, I'm not here with you, obviously, so I'm going to go through all the factors of 28. So you got 28 divided by 1. That's 1, so 28 and 1. 28 divided by 2 is 14. 28 divided by 3 does not work. 28 divided by 4 is 7. 28 divided by 5 doesn't work. 28 divided by 6 doesn't work. And then the next one, 7, brings me right back to what we just found. So these are all the different factors of 28. These are the only ones that we have to choose between. So how do I know which one it is? Well, remember, because these signs are opposites, they're working against each other. So we were looking for the 2 numbers that multiplied to get 28, but had a difference of 12. A difference of 12. Well, 28 and 1, that's not it. 14 and 2 has a difference of 12. It's that. These have a difference of 3. It's not that. So it is 14 and 2. So my last thing is, what sign dominated the middle? Negative. Negative has to go with my bigger factor. Which one's bigger? 14. So it had to be x minus 14. And it had to be x plus 2. So my factors are x plus 2 times x minus 14. Remember, guys, you're not solving. Solving is when you set it equal to 0 and solve. Well, there was no equals up here. There's nothing to solve. You're just factoring. Same for this one. So let's start with our process. Is there a greatest common factor? Well, look at 3. Will 3 go into all 3 of these terms? Absolutely. So let's pull out a 3. 3x squared divided by 3 is x squared. Negative 18x divided by 3 is negative 6x. And positive 24 divided by 3 is positive 8. Now, at the time, we can ignore the 3, but can I factor this? Well, it's 1, 2, 3 terms. I'm going to try to factor this like we just did into 2 binomials. My a value is 1, so this is an easy factor. We're going to go x times x. Now, what multiplies to get a positive? Well, it's either 2 positives or 2 negatives. I look right here in the middle. It's definitely 2 negatives. So we're looking to see what multiplies to get 8, combines to get 6. So here are my factors of 8. I've got 8 times 1. I've got 2 times 4. And that's it. So which ones combine to get 6? 2 and 4. It doesn't matter where they go because both of these are the same sign. So I could put the 2 here, I could put the 4 here, or vice versa. So what are my factors? 3 times x minus 2 times x minus 4. All right, we've done that recently, so I think you guys should be pretty good. Next, solve by factoring. So now we're going to factor it and solve it. So first, you see the equals 0, that's why. We still go through our same process. Is there a greatest common factor? I can pull out a 7, 28, and 28. For sure, I can pull out a 7. So let's pull out a 7. 7x squared divided by 7 x squared, positive 28x divided by 7, positive 4x, and positive 28 divided by 7 again, positive 4. All right? So we're going to try to factor that trinomial into two binomials. What multiplies to get x squared? X times x. What multiplies to get this positive? Well, that's either two positives or two negatives. I look here in the middle, it's positives. So two positives. So we're looking for the two numbers that multiply to get 4, combine to get 4. So my only possibilities are 1 times 4, those combine to get 5, or 2 times 2, and those combine to get 4. So it has to be x plus 2 and x plus 2. So my factors are 7 times x plus 2 times x plus 2. Or you could have done 7 times x plus 2 squared. That's the same thing because you had the same factors twice. Actually, I kind of messed that up. I'm going to put these in the same. Either one is fine. You don't have to do both. Okay, either is fine. You don't have to do both. Now, solving. What are my solutions? Well, think about it, guys. If I take all of my factors, if I take 7 and set it equal to 0, is that true? No. I can't solve that. It just cancels out. But if I take x plus 2 and set it equal to 0, and I set x plus 2 and set it equal to 0, won't I subtract 2 on both of them and x will equal negative 2? Well, do I need to write that twice? No. My solutions are simply negative 2. Now, technically, I would say that it's negative 2 with a multiplicity of 2, but again, that's not important for this particular problem. All right, last factoring problem, number 12. If you look at it, is there a greatest common factor? Will something come out of 2 and 11 and 14? No. It's 1, 2, 3 terms. So I got to factor into two binomials, but A is not 1. And because A is not 1, we have to do over, under. Okay, so here we go. X squared drops down. Minus 11x drops down. But 2 times positive 14 is positive 28. So this is what we're going to factor. What multiplies to get x squared? X times x. What multiplies to get positive? That's either two positives or two negatives. I look in the middle, it's clearly two negatives. And here are all my factors of 28. We got 1 and 28. We got 2 and 14. 3 doesn't work. We got 4 and 7. 5 doesn't work. 6 didn't work. And we just did this one earlier as far as the factors go. But here's where it's different. This time, because these signs are the same, we're looking for the two that multiply to get 28 but combine to get 11. Well, these, 1 and 28, they combine to get 29. That's not it. 2 and 14 combine to get 16. 4 and 7 combine to get 11. So it's got to be 4 and 7. So we're going to come back with the 4 and the 7. Now listen. We went over. You can't forget to come back under. So, will 4 divided by 2 reduce? Absolutely. 4 divided by 2 is 2. So this factor is x minus 2. Will 7 divided by 2 reduce? No. So I'm going to put the 2 with the x minus 7. So my factors are x minus 2 and 2x minus 7. Now what are my solutions? Well, let's take x minus 2, set it equal to 0. I'll add 2. There's one of them. And then if I take 2x minus 7 and set it equal to 0, I'm going to add 7. And then I'm going to divide by 2. Well, 7 divided by 2 is 3.5. So you can either put 3.5 or you could put 7 over 2. Both are perfect. Perfect answers. Okay? All right, so there is factoring and solving. Last couple of problems are just solving equations. So I'm going to go pretty fast because I'm at 35 minutes. I need to finish this off in 10. So first of all, let's solve this one. That's 40 minus 8x equals, I got to distribute negative 8. Negative 8 times x is negative 8x. Negative 8 times negative 5 is positive 40. Now, is there anything I can simplify on this side? No. Is there anything I can simplify on this side? No. Then we need to get our variables together. Remember I told you I always like to move the smaller one? Well, that's the negative 8x, but it's negative 8x on both sides. So when I move it, what happens? They cancel on both sides. Our variables completely canceled on both sides. So what's left over? 40 equals 40. Is that a true statement? Absolutely. Remember, when your variable cancels, there's two possibilities. Either the values equal each other like this, and your answer is all real solutions, or they wouldn't equal each other, and it would be no solution. So in this case, 40 equals 40, all real solutions. Everything works. Anything we'd plug in for x would work. Number 16. Remember, you have to cross multiply. So let's start with 10. What's 10 times 2x? 20x. What's 10 times negative 8? Negative 80. Equals. Now I'm going to cross multiply with the 8. What's 8 times 5x? 40x. What's 8 times negative 9? Negative 72. Negative 72. All right, so I want to get my variables together. So how do I do that? Subtract 20x. It's the smaller one. These cancel. Negative 80 drops down. 40x minus 20x is 20x. Minus 72 drops down. And then, of course, I need to solve for x. Well, solving for x means I need to add 72. Type in your calculator, not your Chromebook, your calculator. Negative 80 plus 72 is negative 8, and that equals 20 times x. So I'm going to divide by 20, and negative 8 divided by 20, you can either reduce it or you can write the decimal. The decimal is negative 0.4, which is nice. So x equals negative 0.4. All right, these are old, and all of us have done these recently. Maybe not real recently, but in the last couple months. Last month. Okay, solve the equation. Remember, we're trying to get r alone. So hopefully you'll recall, we said we want to get rid of this 1/2 first because it's a fraction. And technically, 1/2 is multiplying by r. So technically we divide, but in math, we never divide by a fraction. Instead, we multiply by the reciprocal. And the reciprocal of 1/2 is 2 over 1, which is 2. So we multiply by 2. So that leaves me with 2s equals, remember this canceled, so I'm left with simply RT. So now, what is t doing to r? Again, it's multiplying. So how do I get r alone? Divide by t. So 2s divided by t equals r. Okay? We solved an equation to get another equation. Sometimes we have to do that. Look over at number 18. We're doing the same thing. We're trying to solve for x. So first of all, let's just move this whole term. How do we move that whole term? You add 3y. Now, I can't combine these, so 3x equals 24 plus 3y. So how do I get x all the way alone? Divide by 3. Now remember, That will leave me with x equals, x is alone, right? This is what we wanted. But since 24 and 3 are both divisible by 3, I'm going to use distributive property. What is 24 divided by 3? Well, that's 8. And what's positive 3y divided by 3? Positive y. So x equals 8 plus y. Okay? Hopefully you guys recall that. It's pretty simple. Number 19. Hopefully you guys remember, it says the sum, that means adding, 3 consecutive even integers. Remember, even integers are like 2, 4, and 6. That's 3 consecutive even integers, 2, 4, 6. And we know that the sum of the 3 for this problem equal 42. So it can't be 2, 4, and 6 because those don't add up to equal 42. So the last thing you want me to tell them is, well, what is the middle integer? So here's what we said, guys. Every time you have even integers, you don't know your first one, it's x. Now, how far away is 4 from 2? It's 2 away. So my next one is x plus 2. How far away is 6 from 2? Well, it's 4 away, so x plus 4. And that is how we set up anytime it says consecutive even or odd integers. We're going to go x plus 2 plus x plus 4, and all of that equals 42. So if I combine all my like terms, that's 1x, 2x, 3x's. And then we've got positive 2 plus 4, positive 6, and that equals 42. And now I'm solving a simple equation. I subtract 6, so 3x equals 36. Then I'm dividing by 3, so x equals 12. My first value is 12. My second value is 14. My third value is 16. Check them. 12 plus 14 plus 16 equals 42. So what's my middle integer? That's the question that's asked, 14. So pay attention to the question that gets asked, okay? All right, last one. We have a little bit more challenging. Hopefully you guys recall when we did this. It says the Braves won twice as many games as the Pirates. The Dodgers won 13 more than the Pirates. If they all together won 81 games, how much did each team win? So I told you the first thing we want to do is we want to figure out who is everybody being compared to. You see, the Braves are being compared to the Pirates. See it? Then it says the Dodgers won 13 more than the Pirates. So everybody is being compared to the Pirates. See it? Braves are being compared to the Pirates. Dodgers are being compared to the Pirates. So what do we know? The Pirates are X. Now, what does it say about the Braves? They won twice as many as the Pirates. They won 2 times X. And what does it say about the Dodgers? They won 13 more than the Pirates. They won X plus 13. And all together, so 2x plus x plus x plus 13, all together, they won 181 games. So let's solve. What is 2x plus 1x plus 1x? 2 plus 1 is 3 plus 1 is 4x plus 13 equals 181. Okay, we want to subtract 13. So 181 minus 13 is 168. Your calculator will do that. Divide that by 4, and x equals 42. So guys, the Pirates, who everybody was being compared to, they won 42 games. So how many did the Braves win? Well, the Braves won 2 times that. So 2 times 42 is 84 games. And then the Dodgers, how many did they win? They won 13 more than the Pirates. They won 13 more than 42. So 42 plus 13, 55. And sure enough, if you add those up, it does in fact equal 181. All right, this video is pushing 45 minutes, and that's about how long y'all have in class. So Study this. Test is tomorrow. Hope you have a great day.